Manuel weg. Jetzt ist Manuel weg. Jetzt kann ich raus.
Ach so. Ja, dann
Aber
macht aber auch nichts.
sollen wir starten?
Ja, ja.
Ja. Ladies and gentlemen, welcome back from the lunch break. I hope you all enjoyed the lunch today in this very nice patio, beautiful weather. We ordered that for this week. Last week it was rainy here in Santiago, I've been told. So this week is like our special weather. And I hope you really could enjoy that, the lunch and the weather and being among students actually, which I enjoy a whole lot for this conference. That is really a fantastic atmosphere there. Let me welcome you to the first keynote session of this year's SDE conference. And for this first keynote session, I'm very happy to introduce two keynote speakers. The first keynote speaker is Klaus Hengsbach, and what should I tell you about him new? I guess everybody knows him already. He's from Phoenix Contact, a long-term partner for this conference. He's Director of Tech Education at Phoenix Contact, and in his talk today, he will talk about technical education and what key factor it plays for the economic development and growth. And I hope you will enjoy that as much as I will. And with that, I would say, take it away.
Thank you, Dominik. And I will stay first here. Let's switch it off. No, that's my first page. And I would like to take you with me on a journey with young children. Oh, thank you. Thank you. Wait a moment. Now it's good. Thank you. Thank you so much. Yeah, I would like to invite you to accompany this little girl. Let's call her Camilla. Camilla is a young girl. She will grow up, and yes, what will she see when she will tip this picture, this world? What can we expect? We can expect different perspectives. Perspectives in regarding a bright world with a lot of beauties, but also other kinds of pictures and situations which we are facing, as this one. So it's a kind of really two worlds where we are living on. We have the situation that we have a really blue planet, yes, of course, but everybody of us knows that not on the other side, but also on the same place, we could have also deserts and other dangerous situations. And why? Because we have climate change. Climate change based on CO2 emission, and this CO2 emission influences the world dramatically. And we can change, we have to act to move and stop this dangerous side of the globe through education and also our know-how. And this is what I would like to share with you, because the United Nations also set up this program SDGs, the SDGs, which have 17 marks. And I would like to address 3 points. First, to avoid these poverty. Because you know, we all, okay, are living on the more blue side of the globe. But the other ones, which are also in our mankind and society, are not able to earn more than $2 per day. And this is also the situation which you have to reflect and notice, because education costs also not only time, it costs also money. And when you don't have money, you can't be part in the education field in the world. So we have to think about how we can solve these perspectives. The other ones is qualification and education. And therefore, everybody should have equal access to technology, vocational, on the vocational level, and higher education, and also in the primary school and so on. And when I prepared this speech and looked to Chile, I got a really impressive information, because Chile is regularly on the top level of the South American international test, PISA, and congratulations, it's your work and result, and more than, and this is really impressive, more than 41% of the young adults between 25 and 34 have a college or university degree. And what is the third impressive information is 70% of these graduates are the first member in a family. So it means you grow with education in Chile so fast and stable that you are really proud and have also a bright future in the next years and decades. And yes, of course, the third is energy development worldwide increase 50% since until 2050, sorry. So that means, how can we solve these challenges? The world needs more and more energy so that growing population can live in prosperity and security, of course. And we have in the same reduce CO2 emissions to solve this problem. And we talked with Okerman right now in the moment about AI. AI needs tremendous energy for the data center. And they count for the European market or area that they triple the energy consumption in the next 3 years. Triple in the next year. And this is an amount of 5% of the European energy consumption. So that means we have an increase of energy consumption, and also when we do not do something about CO2 reduction, we have also an increase of CO2. So what do we need? We need innovation and technology And yes, of course, another parameter of development is clean water, for example. We need clean water. Child mortality is reduced from 50% in the last 10 years. So this is a good effect, but also this climate change. Technology has changed our lives, yes, of course. And this is what we are facing also. We have to realize this paradigm shift from oil and fossil resources. We have to change it in the other way, in this kind of energy with renewable energies. And I know from my colleague in Chile, he's not only arrogant, he's also proud about Phoenix Contact. And we are engaged in such projects in Chile and in other countries around the globe. And this means we have here the solar energy park in Chile and other areas. We call this change the all-electric society. What does it mean, all-electric society? A world in which renewable electrical energy as the new primary energy is available worldwide, economically, and accessible for everyone, covering the energy needs entirely. This is our vision of the all-electric society. And this is based also on the know-how of the new engineers and also professors and teachers, lecturers worldwide. And therefore, is it possible or is it impossible? We think it is possible. Yes, of course, it is hard work, it is a long distance, but if we do not do this change, we have tipping points which we can't reverse. And when we pass these tipping points, there are effects like the ice shield in Greenland or other effects we can't push back and to the old situation, former situation. And of course, we have resources. We have to use it, unlimited availability, 10,000 times. Sun is shining and with an energy which we can connect, yes, of course, but we have to use it in different, let's say, applications. And then we have also the wind energy available. And as Phoenix Contact is in both activity plants really active, in the windmills we are with power plugs and also controllers really active, and also in the solar farms we are active with different solutions. We can solve also this. And you see here, of course, it is dominated at the moment with 60% with fossil energies, but we reduced nuclear, and maybe you heard about coal power plants in Germany. Don't trust this information. We have no power plant based on coal or something like that, or we don't have any nuclear plants running in Germany. Yes, we skipped it. We said, no, this is not our future. We need other resources, and therefore we invest a lot in wind, solar, and so on. Yes, and this, therefore, we need these high, let's say, qualified people to solve this challenge in the next years. Okay, storable and transportable. This is really a challenge. When you have windmills, when you have solar parks, then you have to transport this energy to other places where these energies are needed. And therefore, the role of power to X. And here we have solutions for two ways: extraction or electrolysis systems, which can be used in different kinds of solutions. And we are partnering with these technologies, and we have also in Chile some plants where we have windmills and also these extractions of CO2 to produce synthetic hydrocarbons or green hydrogen. And then we can deliver this energy to every part to the world. Power to hydrogen, power to gas, and power to liquid. Yes. So that means the all-electric society future, renewable energies are available worldwide. This is the way in which we have to go, in sufficient quantities and affordable for us, for all. And this means also not only here in the industrial countries, also in Africa and in other developing countries which needs this energy. And then we can produce so much energy as we need by reducing the emission, CO2 emission, to net zero or more. And how? We have to use electrification, network, and automation. And this is the part of Phoenix Contact. We play the role in these kind of solutions. We have competences in all countries around the globe in electrification, networking, and automation. And we are offering also this know-how to universities and vocational schools. Energy efficiency, balancing of generation and consumption. And this is, this is the world where we can use our technology in different fields. In the energy market, of course, in the process technology market, in the factory automation, and this is not only car manufacturing, this is also every product which you want to produce. You can use automation technology. You have to use it. You have to combine it with other infrastructure, let's say, applications, and then it is the all-electric society. It's a combination between a lot of, let's say, fields in one system. And therefore, we need competent experts. This is the key. If we do not have these experts in the energy distribution area or in the charging infrastructure, my colleague Adriano Mones will give also a presentation about EV and charging stations or factory automation or railway. All these belongs to one system which must be connected between all these pictures and centers, also the data centers, which will more and more coming up. And then we have one system which you can control and make it efficient for all of us. How do we do this? How we can shape this future? Selina is tipping to this picture. At the moment you see in the newspaper and in the internet different informations about the western part of requests from the Asian side. They need different solutions in technology, and they have different demands in automation technology. But we have to decide which market is the most efficient for Phoenix Contact as a company. We have to earn money, and therefore, yes, of course, we have to react in technology and innovation, economy and education. We have to create different solutions and concepts also for our partners in education and in business. And therefore, it's really challenging for us to find the right way. And therefore, I'm also so happy to be here, because here we can talk about these challenges and find common solutions to solve these problems or challenges. How do we do this at Phoenix Contact? We are offering different initiatives as we do it here. And with EduNet, this is an initiative from Phoenix Contact, and we founded in cooperation with Professor Langmann in 2017 a foundation so-called, similar to this name, the EduNet World Association, which are responsible for training, education, developing concepts for automation technology and so on. And this is really a really good initiative. And we have also competitions like an international competition for automation technology. And both of these pillars, I would say, are really important for us, because we know that students are motivated to, let's say, realize their ideas about a new world and new solutions. And therefore, this Explore competition we organize every 3 years roundabout. And we invite all the students worldwide in our partner countries to send us ideas about their future, how they would like to realize their ideas. And then we support these universities or teams. And the EduNet initiative from Phoenix Contact is the network for cooperation with universities. We deliver and spend our know-how from the experts from Phoenix Contact and also the technology from Phoenix Contact. And then we have here the network where you could also be a member if you like, and I would appreciate it. And you see here in Chile, you know, Duoc is the most active university, and we counted at that time 13 in total, but I heard from my colleague we have more. We have more than close to 20 universities at the moment, and I took a picture from your website. It's really an excellent cooperation, which is a win-win situation for all of us, for the university, for the company, and as well, at least also for the students, because they go to the labor market and work in different fields in companies. And this is the Explore competition, which I would like to share with you. Here we have also 170 projects and applications, and we invited 100 universities and teams to attend this competition in 2023, and they also won a lot of experience, know-how, and yes, also some meetings. Compared to that, we have annual presentations in China, and maybe also next time with other universities in other countries. What does it mean in total? And this is a figure which impressed me really deep when I saw this number. When you look to the timeline, 15 years ago, and then the number of 385,000 young talents. We got in contact with these, let's say, around about 400,000 young talents who knows now more about automation technology, who knows more about how to work with industry in industry projects. And this is, for me, really impressive because we do this with a small team in the headquarters, but also with a team locally with in our subsidiaries. And there's a saying, Chinese saying, but it fits in every country. If you are a teacher for me for one day, you are a teacher for me my whole life. That's true. Because when you train the student, they remember this content which you trained to or introduced to him his whole life or her whole life. And so you are a part, and this know-how brings them to new, let's say, experience and so on. Yes, we have a full basket of activities, and this is also as we are working with the AHK in different countries really closely, and we do also sponsoring in projects if they apply for some support in their projects in the universities. This is a kind of project which we organized and realized in Morocco, funded by the GIZ and in cooperation with the Central Organization of the Electro Industry in Germany. And as you use the PLC Next technology and the training boards in Chile and other countries, we also used this in Morocco, and all these students and also professors were taught in automation technology on this, let's say, technology from Phoenix Contact, and they were really successful because they moved afterwards to the companies in Morocco, and 700 students got their degree in these 3 years. This was funded by the German government, but the next one was the ETAT project in Thailand, and this was organized by and funded by Erasmus project. And there's one team member, Professor Langmann, who applied with other colleagues from the European side this type of project, and we realized this in also 3 years, and that was related to the needs of the local industry in Bangkok, in Thailand. And we can say we have also an application running for Erasmus related to Chile, and we hope that the European department will confirm the application, and then we can realize and start here in Chile also a new project. Here's the link, but at least we have to work together from the ecological side, from the social side and the economy, because we must solve our challenge together. And then, at least, yes, the future, our common future, is in our hand. And therefore, I would say, it's our task to take this responsibility. It's our task, and also the task from all the other members, families and students and so on, for our next generation, and by using technology and education. And this is, I would say, my statement, at least, that we do it together. We do it in our community on the industrial side. We heard about the activities for Anderson Hall in the morning. I know Festo is also supporting this conference. And yes, come to the universities, or come to the companies. We are going to the universities, and then we have projects together and can share it. And then we can say, here, Camilla, you have a bright future. Thank you.
Thank you, Klaus, for this inspiring speech. We do have a little bit of time for questions. So any questions or comments? Alex, give me a sec to come up to you. That's pretty far away. Starting at the back.
Thank you, Dominic. Thanks, Klaus. That was it's an inspiring vision, and I really like the undertone. And I hate to be negative, but just this morning I saw an announcement on the Washington Post that Donald Trump just signed an executive order to encourage coal production in America and export and so on. So I'm still wondering, how do we as a group navigate this space? Because I think you said, okay, you have a very narrow path to walk as a business, but how do we do it as a group of educators? I guess easy question first, right?
I remember a statement of one of our board members, and they said at that time, we must be also brave to say no, we don't follow these regulations. We don't make this business to support or sell these products. Okay, this is his statement. But it's in our hand to realize it or to do nothing. To only be the answer and not to make it as a business, as because we earn money. When we earn now money, that's from another important, or let's say C-level announcement last year on the conference in Helsinki. Mr. Wendt said, when we don't invest now in these new technologies, we will pay more to the effects which will happen soon and not in the future. And this is the next statement which we have to address to such guys. And also, to say, no, it's not a business. That's not our business. Yeah. We train students to realize and think about solar parks, wind parks, hydrogen, and. And so it's also your task to convince these students to say, it was the past. Fossil energies are the past. Otherwise, the tipping the tipping points achieve in 6 years, only in 6 years. Melting of Grönland, ice shields, and. And therefore, we have no other choice as we say no.
More questions? Well, then I take the right to pose a question myself.
Oh,
sorry,
yes.
Klaus.
Yeah.
No, not off the hook yet.
Yeah.
So I was wondering, you're collaborating with a lot of universities.
Yes. Yes.
And as somebody who's working at a university, I do change.
A hidden company, but as a hidden company, but as a company who has only a small. Okay, please contact who are. Okay, please contact who are you, and then we have to introduce also as SCE conference members. And what I'm, let's say, feel at the moment is that new trends like AI are at the moment not on the screen really in curricula and in concepts. We talk about AI, yes, of course, but that professors introduce AI technology and the usability of this new technology. This is a little bit too less. Of course, we have research projects, for example, to design switch cabinets, simple switch cabinets, based on an AI. They talk or write, yes, right, this introduction and plans to the co-pilot or whatever it is, and they get a really, really good answer, which components they have to use, which more innovative incorporation.
Thank you for that. We do have time for one more question. It is now my pleasure to introduce to us, the second keynote speaker in Australia. And she's now the director of the School of Engineering, Environmental and Natural Resources here at Duoc. So, and because of that, I'm very much looking forward to this presentation. Her talk is very interesting, at least the title is very interesting. The little abstract on the homepage was very interesting, and I'm pretty sure you will live up to that expectations. And I'm not setting the bar very high now, so no worries. So the talk is Recycling of Electronic Waste, a case of urban mining and circular economy. So let us welcome Romina here on the stage.
Let me try this. Great. Good afternoon, everybody. Thank you for joining me in this presentation. Thank you for the introduction. I'm Romina Gayumil, the head of the School of Engineering, Environment, and Natural Resources of Duoc UC. Welcome all of you to STE 2025. I will talk about the recycling of e-waste, electronic waste, a case of urban mining and circular economy. The topic of this year, STEs this year, is all-electric society. So I will give you a different perspective of that, because we have to make sure that if we use electronic equipment, we have to make sure that we can recycle it after their end of life of use, right? So that's why I'm talking about it. The outline will be a little bit of background, then the research process, and then how the project scaled up, community impact, and some concluding remarks. Regarding the background, well, you all know that the growth of the electronics industry has impacted the environment in two ways. First of all, huge volumes of electronic waste are being disposed of throughout the world. Only in 2022, 62 million tons were generated worldwide. I don't know if you knew this before. Have you heard about it? Not really? 62 million tons only in 1 year. That was measured. And also, to manufacture electronic equipment, we need metals from primary resources. For instance, we need rare and precious metals, base metals, and other materials as well. Have you heard the term e-waste before? Yes? I see a lot of term. It's different now, it's up to date, so we changed. So almost 80% of the e-waste is not being formally recycled or even recycled. This data is global, just in case. And if we don't do anything with the e-waste, it's being dumped. And if it's being dumped, we're wasting billions of dollars because they contain valuable materials that we can recover properly, of course. And just 1% of rare earth elements are getting from the e-waste recycling. So 99% of the rare earth metals are being gotten from the mining industry. So I will talk about 3 issues regarding the e-waste generation. The first of those 3 is the transboundary movement. I don't know if you knew this before, but I think it's really important to mention that the e-waste is traveling around the world. Some places like Southeast Asia and Africa receive this e-waste. They treat it in an unsafe way. They recover metals, and someone buy it. So there is a business around it. But the thing is, people surrounding by, they are getting sick because of the unsafe treatments. In South America, we see an arrow there. There's not so much movement of e-waste, and in Chile we haven't seen it. So what happens in Chile is that we are getting the e-waste in the households or in the institutions because only 5% is being recycled. The second issue that I would like to mention is the soil, air, and water pollution. As you can imagine, most contaminants are associated with severe environmental and health issues. These contaminants can disperse through the air, groundwater, and soil, and also people surrounding by, they can get the contaminants in the food chain, so that's why they are getting sick. And the third issue is the use of inappropriate methods to process e-waste. As you can see in the pictures, these are real pictures and old ones as well. There is manual dismantling of the e-waste, open burning, acid digestion, heating or use of nitric and hydrochloric acid. So these methods could be formal if they do it formal, but these are not formal. And they use it in an unsafe manner, like open burning, they just burn it and recover some metals. So after that background, I would like to talk about my research process. So you saw already why it's important to process or treat the e-waste, but in a safe manner. So there are a lot of challenges of the e-waste recycling. As you can see there, a printed circuit board. I think all of you have seen one. And it looks complex, right? So it's a mixture of metal, ceramics, and polymers. So if you want to process it, you have to think about the valuable materials that are present on it. And also you have to think about the hazardous or potentially toxic elements that are also present on it. The composition of all types of electronic equipment and as a consequence of the electronic waste varies over time because there are different functions, different manufacturers, and different types of electronic equipment, so they change over time. And also there are present some elements in trace quantities, so those are difficult to recover and most of them are very valuable. So I decided to go into that challenge and I did my PhD in the recovery of metals from printed circuit boards. That was quite long ago. 13 years ago I started working on this in the study of the recovery of copper-based alloys, precious metals, and carbon-rich materials during the recycling of PCBs. I will call PCB, is shorter, through a high-temperature pyrolysis. So the idea of this process was to recover copper as a main metal of the PCBs, some precious metals as well, and also carbon, because when you process the PCBs, you can get carbon from the polymers. So the composition of the PCBs, as I mentioned before, is never the same between one and another. I'm saying here that this is an average composition, but actually this is just a small study that I did for the composition of PCBs. But in general, it's composed of 30% of ceramics, 30% of polymers, and 40% of metals. And copper is the main metal present in the PCBs because of the conductive characteristics that it has. And it can be present between 13 and 20% in each of the PCB, okay? I'm sorry that it's in Spanish. I forgot to change it, sorry. But in this study particularly, the quantity of copper was 18%, and other metals present were aluminum, zinc, lead, nickel, tin, and others. So I had to think how to treat the PCBs. So first of all, it took me 4 years to decide how to do it, and make it work. And so I started working on a high temperature pyrolysis atmosphere. That means we have to flow an inert gas, such as nitrogen or argon, to make sure that there's no oxygen in the furnace. So why that? We decided what temperature work with. And that was quite difficult because as copper is the main metal present in the PCBs, we should think, okay, we should melt copper. If we melt copper, we can recover precious metals with it because they have a high affinity. And that's what I did. But the sample is not only copper, it's a mixture of ceramics, polymers, and metals. So I decided to work at temperatures higher than the melting point of copper. That was from 1150 degrees till 1350 degrees. So I did my first experiments, and what happened is that worked. I could melt the copper, concentrate the precious metals, separate the phases. That means separate the non-metallic fraction from the metallic fraction. It was a huge discovery, and it worked. But we have lead on it. And lead at high temperatures, they get into the gas stream. So that was a really bad result. So it worked in one side, more difficult because we usually melt copper to concentrate precious metals. So we have to decide to work in a different range of temperatures, but high enough to not contaminate the environment. And that means the dioxins and furans that could be generated, that work at a certain range of temperatures. That's lower temperatures than 800 degrees. So I tried to work at 800 till 1000 degrees, so below the melting point of copper, but high enough to not contaminate the environment. So what happened is that the phase separation occurred anyway without melting the copper, and concentrated the precious metals and keeping the lead solid and not in the gas stream. Good results. So I'll show you these pictures. These are real pictures that I took myself. I used to work with the PCBs, a mixture of PCBs that I treated at that range of temperature. So the carbonaceous phase is mainly composed of carbon, up to 70% of carbon, depending on the type of PCB I used to work with. The copper-rich phase contains copper, of course, and contain the precious metals as well. And the tin lead phase kept the lead solid, so good results. So coming back to the advantages of the process, no prior mechanical processing was needed because only size reduction of the PCBs was carried out. So we reduced the amount of energy we need to process the PCBs. After that, reduction of the working temperature is really good news because we save 4,000 degrees during the process. I forgot to say that this is a batch process, not continuous. So we can stop doing it, get in the material, and do it again. The two metallic fractions were formed. One of those concentrated the precious metals, that is gold, silver, platinum, and palladium. Those were concentrated within the copper. And the non-metallic fraction was a carbon-rich one, and we could reduce, I said we because we were a team working on this. We reduced the volume of the material up to 75%. It was prevented the generation of greenhouse gas emissions because of the pyrolysis, right? Because of the absence of oxygen. And also some metal particles could be captured from the gas phase. So we prevented to emit it to the atmosphere. So that furnace, that's the experimental arrangement. That furnace works with energy. It's an electric furnace. There are different types of electric furnaces. This was an horizontal tube furnace, but any other furnace could be used. So the flow chart is more or less like that. That's also in Spanish, I'm sorry. The pyrolysis of PCBs could be the nitrogen or argon can be injected within the furnace, separation of the phases, carbonaceous one in one side and gaseous one in the other side. And the carbonaceous one is mainly composed of carbon, as I mentioned. Then the metallic phases, one rich in copper and precious metals, and the other one rich in lead and tin. And I already showed you that. Several papers were published, so if you're keen of reading it, just ask me later. So how the project scaled up? I finished my PhD, and then I came back to Chile and thought, okay, how can I keep working on this? So I had to know, first of all, what's the reality in Chile? So today, up to 10 kilos of e-waste per capita are generated every year. That means 200,000 tons every year, and only 5% is being collected and treated formally. 95% is being kept in our households, hopefully not dumped, hopefully, we don't know. Local companies, what they do, they collect, dismantle, and separate the valuable components, and they are exported. So what they do, I'm going here, they do half of the recycling chain, and the other half is being carried out overseas. Polymeric materials are being recycled locally, and the metallic products are being recovered abroad. So what the local companies do, they do the half of the recycling chain. They export it to countries like Belgium or Japan, where they actually do the circular economy, recover the metals, and put it in the market again. We also have the extended producer responsibility law in Chile, and that mandates that producers are responsible for the management and financing the wastes that they are generating. Particularly, e-waste is one of the priority products to promote recycling and reduce environmental impact. So after that context, Chilean context, what has happened with my work, there was a validation of the process here in Chile in collaboration between industry and academia. That was long ago, maybe 7 to 8 years ago. So the processing of PCBs was carried out in Chile. It worked same way with different types of PCBs. The lower lower range to higher range of valuable metals present on it. Also, a research on the refining products was carried out. It's not finished yet, a lot to do there, but the processes that are being used are metallurgical processes that are being known for everyone. Also, a research on LED, LCD screens was carried out, and also the pre-treatment of solar panels. So a wide range of research has been carried out to process the e-wastes locally, hopefully. Both work in collaboration between the industry and academia. The goals, of course, investigate the e-waste recycling locally, recover valuable materials, and minimize pollution associated with the treatment and disposal. So the project evolved with me, maybe. So you saw the recycling chain. The recycling chain starts with the collection step. So when I came to Duoc, I thought, okay, there's a huge opportunity of do a collection project. So what we did with my team in the school, we put this project on. We started in 5 campuses of Duoc, and then we did an alliance with Pañihue, which is the local e-waste manager, and Mitsubishi Materials, that maybe you've heard about them. They are the ones that are treating the e-waste in Japan, so we did an alliance with them as well. What was the target audience? Students, teachers, and administrative staff. And the project grew a lot. So we are already doing the project in 16 of the Duoc UC campuses. We started in September of 2023. It's been 1.5 years already, and the results, well, the container is like that. It's like 1.5 meters high, and it has a sensor on it. So the Pañihue, the company, they know when it's filling up. So up to 60 to 70% they come, and they collect the e-waste, and then they put it again in the campus to keep working on it. So the results so far, we've collected 30 tons to date in 1.5 years. As I mentioned, we started just for 4 months in 5 campuses of Duoc in 2023. And mentioned before, I skipped it, but it's really important. Mention that we are very into the sustainable development goals as well. So I just mentioned the number 17 alliances, but this project is related to other SDGs as well. So these 30 tons means that we have mitigated the emission of 19,000 kilos of CO2 so far. And that means as well that we have preserved a total of 9 hectares that capture carbon for 1 year. And also this project grew again. So we made an alliance with Catholic University. So they also put containers in their campuses. So what has been the community impact? Well, you can imagine that properly and safely disposed institutional e-waste and community e-waste. So we are giving the whole community a proper container, and we know that circular economy will happen because we have traceability of the project. We work with the local e-waste manager and with Mitsubishi, so we know what's happening with the e-waste. Also strengthen the fundamental pillars such as academic quality, partnerships, and globalization. This is very important for us because in the school we are putting a lot of attention to sustainability, and one of the topics that we have in the 17 programs that we have in the school is sustainable development. Also promote a cultural shift towards sustainability through the awareness of the management and e-waste processing in Chile. And also encourage the training of specialized professionals in sustainability topics. But I know you know this, We are the biggest copper producer of the world, and we have the higher smelting capacity of Latin America. So these kind of processes can eventually be implemented in Chile because we have the capacity. And also, I'm a metallurgist. I studied metallurgical engineering from my base formation. And usually we use the knowledge of metallurgy. It's associated with the mining industry, and it could be used in waste management and recycling. That's what I did. Also, these new approaches provide solutions for future material scarcity of the mineral resources. Also, the development of safe practices for the e-waste management, because I mentioned at the beginning, there are a lot of unsafe processes that are being carried out throughout the world. Also, the importance of the industry and academia alliances. That's something we are talking about these days, right? So keep talking about it, because I don't think we can do this alone, the sustainability area, but also along the different programs, we have to keep working and talking about the sustainability topic. And before finishing, I'm leaving you my contact if you want to keep talking about it or other topics maybe. So that's my LinkedIn and my email address. So thank you for listening. I'll be happy to listen to your comments or questions. Thank you so much.
Thank you, Romina. That was highly interesting. Are there questions and or comments?
Yeah, thank you, Romina, for the interesting presentation. In your work, did you consider also the economical and the ecological aspects, and did you compare it with the amount of energy and time and resources to get these resources out of e-waste compared to like mining it from mineral fields? Is there like a value or something?
There is, but it was done by a different team. I used to work, I said I used to because I stopped doing research by the moment, but there is a study that brings together economical and environmental footprint of the process as well. Economically, it's very good. I couldn't say an amount, but that's why the local companies work on it, because they get a lot of money back. But it has to be like that, because otherwise, if there's no business, nobody will do it. But I can answer the strict amount. But yes, thank you.
Hi. My question is about, with respect to e-waste, there is so many types, starting all the way from electrical systems all the way to complex electronic systems. So when you say that you're kind of subjecting it to high temperature, is it the whole thing, or you have any segregation process to separate out components, or how exactly is your experiment focused on in trying to deal with this complex waste infrastructure?
Yeah, I will put the example of the local e-waste manager company, Pañihue. What they do, they get the whole types of e-waste. They actually separate the different parts. The different parts are polymer-rich, or maybe hazardous materials, or maybe magnetic materials, electrical materials, and there exist processes for that. Usually the big companies that they do the recycling chain complete, they use the mechanical processing. I didn't, because I worked only at lab scale. And that's why I mentioned that I just did the size reduction and didn't use mechanical processing. But when I used to study the LCD screens, we do with the team the whole processing, and we needed to do mechanical processing, but no magnetic or electric separation, so the amount of energy was mainly focused on the mechanical itself. I don't know if I answered the question.
Yeah.
Thank you.
More questions? Before I go down there, any questions up here?
Klaus?
You cooperated with Mitsubishi, and is Mitsubishi now promoting this in other countries as a role model?
I don't know the answer, really, because we work with Mitsubishi Materials Chile, and it's not common for them to do agreements. They told us. So they work in Chile in the mining industry, not in the recycling one necessarily. Probably they are starting working on the recycling area, and they knew, actually, they found us and not us to them, because they knew about the project, they were very interested, and now we work together, the three areas like Pañihue, they, and us together. But I don't know if they've done this before, actually. Yes, because companies bring back to Japan all the e-waste, and it's quite common for them to do it. Other companies in Chile, they also do it, but there's no agreement between them, just a contract. And for us as an institution, we are very proud to have this agreement because we know the traceability of the project. Thank you.
Okay, thank you, Romina. I'm from Belgium, Erwin Smith from the University of Belgium, and in fact our campus is well, very close to a big company, Union Minière. You know the company, which is doing
Yes.
Recycling, but they use, I think, another process. And I just want to inform you, but I think you know it, that they are now investing a lot because this is really a hot topic.
Yes.
And I was wondering whether the system you developed or the process you developed has advantages regarding to the ones they are using.
Yes. This process is just for PCBs. There's no mixture of other materials. Usually the processes that are used in Belgium or Germany or even, but this one is just for PCBs. It's not for a mixture of e-waste. It has to be for PCBs. It's a batch process. So it can be implemented in another process. I haven't explored that yet, but it's just for PCBs. That's the main difference.
Okay, so it's important that the input of your products is in control, that you have grip on that, in fact. And then it's good that now
but
only PCBs.
Yeah, but those kind of processes also, the mixture of different wastes is very different. I think in Umicore, maybe, they mix different type of wastes all together in one process. Other processes are with the copper mining industry together with the waste. So the mixture of materials is different in each process, finally. So that's the main difference.
Thank you.
Thank you.
More questions?
You mentioned that the polymers were just turning into carbon and that the metals build alloys which can be separated. What about the ceramics? Do they just remain and can be separated out mechanically?
They remain in the carbonaceous phase as an oxygen compound-based compound. I mean, like alumina or silica, they stay, they don't react at those range of temperatures. So that's something that I found out during the process. Polymers react at lower temperatures than the metals, and then the metals react, and then the ceramics react. So I didn't work at temperatures that ceramics react. So that's why they stay solid, in solid state in the carbonaceous phase.
Okay. All right. Thank you.
Thank you. You had a question, right?
To introduce the system for it to be used here on campus, and did you see any immediate reactions, or did you see something like vandalism as well? Because that's something that we sometimes see when we collect old clothes. or did you maybe see something positive or even more positive than what you've shown? Are there any societal aspects that you can tell us about?
Thank you for your question. We work this project with the sustainability area of TWOC, so we work together implementing this project. So we had ambassadors in each of the places. So that was really key aspect of the project because they were, they not only work on the recycling or e-waste recycling, but also in the whole sustainability topics. But the cultural change, School of Communication as well. So we try to spread the word, actually. And then the second year, that was last year, in the campuses that they already had the container, it was quite much easier to work with because people knew that they had the container and you see the people bringing the e-waste and put it in the bin. But in the new ones, we have to keep working on it. No vandalism, that's good news. We've seen a couple of cans, that's it. Maybe the cultural, something that we have to work with. Hopefully this year we'll open the project to the community surrounding the campuses. So we'll see what happens. Thank you.
Okay, I have a more technical question. For instance, if you have an electronic device as an e-waste, maybe a circuit board or so on, and when this device is 100%, what amount of recycling you can do it, or grade of recycling? How many percent? 50, 67, and I mean, what is at the end of a recycling process? What is the real e-waste, which you cannot more recycle?
It depends on the device, because some of the devices have much more content of the hazardous materials, and when it's hazardous material, at least in Chile, they keep it disposed of in a closed place. There's no processing in Chile of the hazardous materials. That's bad news. But trying to answer your question, it depends on the electronic equipment. It depends on the function of the equipment. And it depends if it exists a process to process the e-waste. For instance, in Chile, we do these whole campaigns to recover the PCBs because those are the valuable materials on the e-wastes, but the screens, for instance, is quite difficult to recycle because there's no recycling process in Chile. That's why we work in this project. And the amounts vary depending on the type of electronic equipment, so my answer is very difficult to say because it depends on the type. But from the European Commission, there is categories of the e-wastes. And if we could work with categories, it's much easier to estimate. Otherwise, it's very difficult. We don't work with the categories in Chile. Thank you.
Well, let me comment on that project a little bit because I really love to see your presentation. It was highly interesting. And what stood out to me actually was on your last slide where you were talking, or maybe the second to last, where you were talking about that your metallurgical scientist, right? That's what you are, exactly. And what I really enjoy there is seeing that you, in a field that is a core engineering field, like material science, for example, you can use this knowledge not only to the traditional fields or the traditional industries, but also to very important industries and branches that are important for us at the moment and for the future. And I think that is a stellar example of exactly that, using core engineering knowledge and science for such a project. And I would be interested in, if you know that, if there are students, how do the students react to that? So I guess you're also working with students in this project, and what happens to them when they also realize that well, the knowledge I learn here, I actually can use that in these fields, even though I'm in a very core engineering field. So what is their feedback in that area?
I must say that when I started doing my PhD, people thought that I was crazy because I left the mining industry and started working on the recycling industry. But today is very different, so that's good news. The students' reaction, they wanted to work in the recycling industry because they knew the projects, they worked on the projects, they knew that they were capable of doing it, and all the core, the whole program of metallurgy could be put in the, could work for the recycling processes. Not only pyrometallurgy, that's high temperature processing, also hydrometallurgy as well, and those two are the core, how can I say, courses in metallurgy, and they could work on both in the projects. So their reaction was like, I want to work on this, but I don't know where to work. So finally, they are or doing masters or PhDs today, and or working in the mining industry or working in innovative companies.
That is really fantastic to hear. Great. Last call. If there's no additional question, I think Romina will be with us during the 3 days,
Yes.
I guess. Awesome. So if you come up with more questions, I'm sure she will be happy to answer that.
Yes. You can answer as well.
Yeah. Thank you again for your talk.
Thank you so much. Thank you.
And this concludes our first keynote session. To just give you a little bit of an orientation for the rest of the day, we will now go into the second coffee break, I guess again in the patio. Great. After that, we will have the first separate sessions in this room here and also in the other classrooms. Please keep an eye on the program for any last minute changes. There shouldn't be any, but well, you never know. And after those sessions at 6, we will have our welcome drink, our social event, the welcome drink. Do we meet upstairs right away or do we meet elsewhere? No, we meet upstairs right away, right? Okay, so the welcome drink, as you might have seen in the program already, is in the big tower on the 15th floor. It's very pretty up there. You can see the whole city, and we will meet there for gathering, for having a really good time at 6. So right after the sessions, you can directly go there, take the elevator. I hope there's not a long line, but I guess there will be. And then we meet up there for the welcome drink, and I hope to see you all there. So far, thank you very much, and see you later.